Professor Dave here. Let's talk about inequalities.
He knows a lot about all kinds of stuff. Professor Dave explains.
Algebra is all about equations. One side equals the other side, and we move things around until we can solve for a variable. But there is another type of construct in algebra that we will need to use, and it is related to the equation. It is called the inequality. Instead of an equation that equates two terms, telling us that they are equal, an inequality tells us how two terms are not equal, but rather that one is either greater than the other or less than the other. We can manipulate and solve inequalities exactly the same way that we manipulate equations, with one or two tiny additional rules. So let's take a look at these now. First, let's examine something simple, like x is greater than 3. Unlike a simple equation where x has precisely one value, x has many values, and any value for x that satisfies the inequality is a solution for x. 4 could work, or 10, or a billion, or 3.00001. Any number imaginable that is bigger than 3 is a solution to this inequality, and this can be represented on a number line using an open circle, implying that 3 is not part of the solution. Anything less than or equal to 3, like 0 or negative 3 or 2.999 or 3 itself, will not be a solution. We will see inequalities set up like some of the equations we've seen as well. How about x plus 2 is less than 7? As you might expect, all we do is subtract 2 from both sides, which gives us x is less than 5. So any value less than 5 is a solution, while 5 or above is not. We will also see these symbols, which mean greater than or equal to and less than or equal to. These work the same way as the other symbols, except that they include the specific value shown rather than excluding it. If we have 3x plus 4 is greater than or equal to 16, we subtract 4 from both sides, then divide by 3, and we get x is greater than or equal to 4. Now on the number line, we represent this with a closed circle, meaning that it is filled in rather than empty to represent that the number 4 is included in this solution. So everything here works the same way it does with equations, but there is one difference we need to point out. If we are multiplying or dividing by a negative number, we need to reverse the direction of the inequality symbol. For example, if negative x is greater than 6, we would either multiply or divide both sides by negative 1 to get x. But if we do that, we have to switch the greater than to a less than. X is less than negative 6. To see why this is the case, let's test this solution. Take the first version and plug in negative 10. The negative version of negative 10, or the opposite of negative 10, is 10, and that is indeed greater than 6. Now with our revised version, negative 10 is also less than negative 6. So we can see that this flipped version is indeed the correct counterpart. One way of rationalizing this is by looking at a number line. First, let's remember that negative numbers closer to 0 are larger than negative numbers farther away from 0. So although it may for a moment seem like negative 10 is bigger than negative 5, it's actually the other way around. Then we must understand that when we multiply and divide these values by positive numbers, we are just stretching and shrinking the line as it is. But if we multiply or divide by a negative number, we are inverting the sign for every value, which makes it look like the mirror image of the number line. To compensate for this, it makes sense to flip the whole thing over, which is essentially what is achieved by flipping the sign of the inequality. We can verify this by using whole numbers. 1 is less than 2, but if we multiply by negative 1, we would get negative 1 is less than negative 2, which is not true. The only way this remains accurate is by flipping the symbol to get negative 1 is greater than negative 2. Other than this little rule, which can sometimes be tricky to remember, solving simple inequalities like this is no different than solving simple equations. So let's check comprehension. Thanks for watching, guys. Subscribe to my channel for more tutorials. Support me on Patreon so I can keep making content. And as always, feel free to email me, ProfessorDaveExplains@gmail.com.